Hey everyone, it's Sir B here. We hear it all the time. Data is the new oil. But what exactly data, and why is it so important to understand its different types and classifications? Well, whether we realize it or not, we encounter data every single day. From the number of steps we take to the comments we read online, data surrounds us. And just like there are different types of tools for different jobs, there are different ways to classify and measure data depending on what we want to learn from it. We'll explore the different types of data, how we classify them, and why it matters when it comes to analysis. Get ready to demystify data. Data is everywhere. From survey results to scientific experiments, understanding the types and classifications of data is essential for analysis. Alright, let's kick things off with the two main types of data, qualitative and quantitative. Think of these as two different but equally important flavors of information. Qualitative data is all about describing qualities or characteristics. It's the kind of data that paints a picture with words rather than numbers. Imagine you're conducting a survey about people's favorite ice cream flavors. Their responses, chocolate, vanilla, strawberry, that's qualitative data. It's about descriptions, categories, and often involves collecting information through text or images. Quantitative data, on the other hand, dives into the numerical realm. It's all about measurable amounts or counts. Going back to our ice cream example, if we ask people, how many scoops of ice cream do you eat per week? The answers we'd get, 1, 2, 3, or maybe even 10. For the truly dedicated, that's quantitative data. We're talking numbers, quantities, things we can measure and analyze statistically. Now you might be thinking, okay, that makes sense, but why does it matter? Well, understanding the type of data you're dealing with is crucial because it dictates how you analyze it. Let's say you're a marketer trying to understand customer preferences for a new product. You might run a focus group, gathering qualitative data through open-ended questions about what people like or dislike. This kind of data helps you understand the why behind consumer behavior. But you might also collect quantitative data, like sales figures or website traffic, to track the actual impact of your marketing campaigns. See, both types of data work together to give you a complete picture. Qualitative data is like the descriptive narrative, providing rich insights into thoughts, feelings, and experiences. Quantitative data, on the other hand, is your numerical toolbox, allowing you to measure, compare, and draw statistical conclusions. So, whether you're analyzing social media trends, conducting scientific experiments, or simply trying to make sense of the world around you, remembering the distinction between qualitative and quantitative data is key. Welcome back. Now that we've got a handle on the two main types of data, qualitative and quantitative, let's dive a little deeper into the world of numbers and explore the two main classifications within quantitative data, discrete and continuous. Think of discrete data as the data that can be counted. It consists of whole numbers representing distinct, separate values. Imagine you're counting the number of students in a classroom. You can have 20 students, 21 students, but you can't have 20.5 students. That's discrete data. It's all about those whole countable units. Other examples of discrete data include the number of cars in a parking lot, the number of likes on a social media post, or the number of books on a shelf. Continuous data, on the other hand, flows smoothly along a continuum. It can take on any value within a given range, including fractions and decimals. Think about measuring the height of students in a classroom. You might have someone who is 5 feet 6 inches tall, someone who is 5 feet 7.25 inches tall, and everything in between. Continuous data is all about measurement, and those measurements can get incredibly precise depending on the tools we're using. Other examples of continuous data include temperature, weight, time, and even the speed at which a video is buffering, all those values that exist on a spectrum. Now, just like understanding the difference between qualitative and quantitative data is crucial for analysis, distinguishing between discrete and continuous data is equally important. For instance, let's say you're a researcher studying the effectiveness of a new medication. You might collect discrete data on the number of patients who experience a reduction in symptoms, but you might also collect continuous data on the degree to which their symptoms improve, perhaps using a scale of 1 to 10. The type of analysis you perform on discrete data versus continuous data will differ. So, the next time you encounter a set of numbers, take a moment to consider whether they represent discrete, countable values or continuous, measurable values. Chapter 3. Levels of measurement from nominal to ratio. Welcome to the final level of our data deep dive. We've talked about qualitative versus quantitative data, and we've unpacked the world of discrete and continuous data. Now let's explore the fascinating realm of levels of measurement. This concept might seem a bit abstract at first, but trust me, it's incredibly important for understanding how we analyze and interpret data. Think of it like this. Not all numbers are created equal. The level of measurement refers to the relationship between the values assigned to attributes or characteristics. Basically, it tells us how much information a particular type of data actually contains. There are four main levels of measurement: nominal, ordinal, interval, and ratio. Let's break them down one by one. Nominal data is the most basic level of measurement. It deals with categories that don't have any inherent order or ranking. Think of it like assigning labels or names to different groups. For example, if we were collecting data on people's eye color, we might use categories like blue, brown, green, and hazel. There's no natural order here. We can't say that one eye color is higher or lower than another. Other examples of nominal data include gender, marital status, or the types of cars people drive. Now let's move up the ladder to ordinal data. This level of measurement introduces the concept of order or ranking. With ordinal data, we can say that one category is greater than or less than another, but we don't know the exact difference between them. Think about a survey that asks people to rate their satisfaction with a product on a scale of 1 to 5, with 1 being very dissatisfied and 5 being very satisfied. We know that a rating of 5 is better than a rating of 4, but we don't know if the difference between 4 and 5 is the same as the difference between 1 and 2. Other examples of ordinal data include educational attainment, for example, high school diploma, bachelor's degree, master's degree, socioeconomic status, for example, low, middle, high, or even the ranking of runners in a race, first place, second place, third place. Next up, we have interval data. This level of measurement builds upon ordinal data by introducing the concept of equal intervals between values. With interval data, not only can we say that one value is greater than or less than another, but we also know the exact difference between them. The classic example of interval data is temperature measured on the Celsius or Fahrenheit scale. The difference between 20 degrees and 30 degrees is the same as the difference between 40 degrees and 50 degrees, a nice even 10-degree interval. However, there's a catch with interval data. It lacks a true 0 point. What does that mean? Well, in the case of temperature, 0 degrees Celsius or 0 degrees Fahrenheit doesn't actually mean the absence of heat. Other examples of interval data include calendar years or IQ scores. Finally, we arrive at the most informative level of measurement: ratio data. Ratio data has all the properties of interval data: order, equal intervals, but it also includes a meaningful 0 point. This means that with ratio data, we can not only compare the differences between values, but we can also talk about ratios and proportions. For example, height, weight, and income are all examples of ratio data. The existence of a true 0 point allows us to perform a wider range of statistical analyses with ratio data compared to the other levels of measurement. So why does all this matter? Well, understanding the level of measurement is crucial for choosing the appropriate statistical techniques for analysis. The level of measurement determines the richness and complexity of the information we can extract from data. And there you have it, a whirlwind tour of data types and levels of measurement. We've covered a lot of ground, so let's recap the key takeaways. First, we explored the two main flavors of data: qualitative, which describes qualities and characteristics, and quantitative, which deals with measurable amounts. We then delved into the world of quantitative data, distinguishing between discrete data, consisting of whole, countable units, and continuous data, which can take on any value within a given range. Finally, we climbed the ladder of levels of measurement, starting with nominal data, which involves categories without any inherent order, and moving all the way up to ratio data, which includes order, equal intervals, and a meaningful 0 point. Understanding these fundamental concepts is essential for anyone who wants to make sense of the vast and ever-growing world of data. Want to learn more? Subscribe for more insightful videos.